NASA says its Voyager 1 probe, the most distant human-made object in the universe, is sending usable information to Earth again.
NASA engineers have re-established communication with the Voyager 1 spacecraft.
For over 45 years, Voyager 1 has been a remarkable source of information, sending back data that has deepened our understanding of the universe. Recently, however, this spacecraft has made a discovery that has raised concerns among scientists. Even more perplexing is the fact that this issue hasn't triggered the spacecraft's safe mode, a protective state designed to safeguard Voyager 1 from potential harm. These findings have left scientists with many questions. What exactly has Voyager 1 encountered in the depths of space? Could this discovery pose any risks to Earth? Join us as we delve into the reason why NASA warns Voyager 1 has made an impossible discovery after 45 years. The mission of the twin Voyagers. September 5, 1977 saw the launch of Voyager 1, a spacecraft destined for one of the most extraordinary journeys in human history. Voyager 1's mission began from Cape Canaveral, Florida, aboard a Titan IIIe Centaur rocket. Just 13 days earlier, its twin, Voyager 2, had embarked on a similar mission. The twin spacecraft were initially tasked with studying the moons of Jupiter and Saturn. Two of the largest planets in our solar system, Jupiter and Saturn, formed about 4.5 billion years ago, likely migrated outward from closer to the Sun, much like our planet is gradually moving away. Understanding their evolution, including the formation of their moons and rings, would provide valuable insights into the development of our solar system and other solar systems that may have planets similar to our gas giants. And that's why the spacecraft was sent out. However, the Voyager's mission quickly expanded beyond their original goals. Both spacecraft have traveled farther from Earth than any other man-made objects, reaching the farthest regions of space that we have ever explored. Today, Voyager 1 and Voyager 2 are over 12 billion kilometers away from Earth. Yet they continue to send back data that amazes scientists. In their journey through the outer solar system, the Voyagers made several groundbreaking discoveries. Contrary to earlier beliefs that the moons of Jupiter and Saturn were cold, dead worlds, the Voyagers revealed them to be surprisingly active. For instance, Voyager 2 was the first spacecraft to fly by Uranus in 1986, and the only one to visit Neptune 3 years later. These encounters provided new information about these distant planets, including Neptune's intense winds, icy volcanoes on its moon Triton, and previously unknown moons around Uranus. The Voyager spacecraft were designed with precision, rotating 15 times slower than the hour hand on a clock. This slow rotation helped reduce image blur as they sped through space, allowing them to capture clear images and detailed data. Even before reaching the outer planets, the Voyagers sent back stunning images of Jupiter's swirling clouds and its great red spot, capturing the imagination of both scientists and the public. These spacecraft, though built in the 1970s, still use 8-track cassette technology to store important scientific data. At the time of their design, digital storage technology was not yet advanced, so 8-track tapes were chosen for their reliability and durability. These tapes have preserved invaluable information about the outer planets, their moons, and the space beyond our solar system. The Voyager's discoveries and eventual separation. Voyager 1 has been on an extraordinary journey since it was launched. After decades of exploration, it has now ventured into interstellar space, a region beyond the heliopause, the boundary where the sun's influence ends, and the environment is shaped by forces from other stars. Although Voyager 1 was launched after its twin, Voyager 2, it took a faster route and exited the asteroid belt ahead of its sibling, overtaking it on December 15, 1977. During its mission, Voyager 1 made several significant discoveries, including a thin ring around Jupiter and two new moons, Thebe and Métis. When it reached Saturn, it found 5 more moons and a previously unknown ring, the G-ring. One of Voyager 1's most intriguing encounters was with Saturn's moon Titan, where it discovered a thick, hazy orange atmosphere full of complex chemistry. Titan's atmosphere has fascinated scientists because it resembles what Earth's atmosphere might have been like before life began. Each flyby of a planet or moon brought new questions and a wealth of data, challenging our previous understanding of these distant worlds. Another of the most surprising discoveries made by the Voyager was the detection of active volcanoes on Io, one of Jupiter's moons. Io turned out to be the most volcanic place in our solar system, with towering plumes of volcanic material constantly reshaping its surface. This discovery, along with the exploration of other moons, greatly expanded our understanding of these distant worlds. Pele, a prominent volcano on Io, is one of the most striking features of Jupiter's moon. With eruptions that can reach heights 30 times greater than Mount Everest, Pele is truly a spectacle of nature. Its eruptions also cover an area approximately the size of France. The Voyagers also found evidence of a possible subsurface ocean beneath the icy crust of Europa, another of Jupiter's moons. This finding raised the possibility of extraterrestrial life. As such, an ocean could potentially harbor living organisms. The Voyager spacecraft, which captured over 33,000 images of Jupiter and its moons, provided humanity with an unprecedented view of the Jovian system. The discoveries made by Voyager have significantly broadened our understanding of the variety and complexity of celestial bodies, even in the farthest reaches of our solar system. Additionally, the Voyagers discovered geysers on Saturn's moon Enceladus, hinting at the presence of liquid water beneath its surface. These revelations have encouraged further missions to explore these moons and their potential for supporting life beyond Earth. In addition to enriching our knowledge of the outer planets and their moons, Voyager 1 and Voyager 2 have provided invaluable data during their journeys into interstellar space. Their study of the heliosphere, a vast bubble-shaped region dominated by the solar wind, culminated in their crossing of the heliopause. The heliopause marks the boundary where the solar wind's influence diminishes and interstellar space begins. Voyager 1 and Voyager 2 became the first human-made objects to enter this uncharted territory, achieving this milestone in 2012 and 2018, respectively. This transition has greatly enhanced our understanding of the boundary between our solar system and the rest of the galaxy, offering scientists a wealth of information about magnetic fields and interstellar plasma. Triton, Neptune's largest moon, is another fascinating discovery made by the Voyagers. Triton is one of the coldest places in the solar system, with surface temperatures plunging to as low as -391 degrees Fahrenheit. Despite its frigid environment, Triton displays some peculiar and dynamic features, including ice volcanoes that eject icy particles, and nitrogen gas up to 5 miles into its thin atmosphere. The observations made by Voyager 2 during its encounter with Triton have provided valuable insights into the processes shaping the Moon's surface and atmosphere. After their encounters with Jupiter, the Voyagers took separate paths, each exploring new and uncharted territories. Voyager 1's trajectory brought it close to Titan, Saturn's largest moon, which is enveloped in a thick orange atmosphere. The data collected during this flyby sparked further research into Titan's complex composition, as its atmosphere is rich in organic compounds and may hold clues about the early conditions that led to the emergence of life on Earth. Following its close encounter with Titan, Voyager 1 ascended out of the planetary system, heading toward interstellar space. The impossible discovery, made by Voyager 1. As the Voyagers traveled further into space, their instruments continued to send back crucial scientific data. NASA has implemented careful measures to conserve the Voyagers' remaining energy, aiming to extend their missions for as long as possible. By managing energy supplies and shutting down non-essential systems, the spacecraft are expected to remain operational until at least 2030. The data they continue to return will significantly enhance our understanding of the interstellar medium and the outermost regions of our solar system. The use of gravity assist techniques has been key to the success of the Voyager missions, allowing them to explore distant parts of the solar system that would otherwise have been beyond their reach. As the Voyagers journey farther into interstellar space, they continue to make new and unexpected discoveries. One of the most surprising discoveries made by Voyager 1 in recent years is the unexpected increase in cosmic rays in interstellar space. This has prompted scientists to reconsider their theories about the interstellar medium. which is the vast space between stars filled with gas, dust, and cosmic rays. The data collected by the Voyagers on magnetic fields, plasma waves, and cosmic rays is proving invaluable in helping us understand the composition of interstellar space and the forces that shape our galaxy. As the farthest human-made object from Earth, Voyager 1 has detected constant, faint signals from interstellar gas. These signals, which astronomer James Cordes likened to a gentle rain, with occasional bursts similar to lightning in a storm, suggest that there is more quiet activity in the interstellar gas than previously thought. This allows scientists to study how this gas interacts with the solar wind from the Sun, providing important new insights even in the absence of solar events. Another particularly intriguing discovery is a strange faint hum that Voyager 1 has picked up from deep space. This hum, which has sparked much curiosity, is a persistent signal that scientists believe comes from interstellar plasma waves influenced by the Sun. The finding, made by a team from Cornell University, has captured the attention of scientists and the public alike. However, this impossible discovery has also led to some more imaginative speculation. Some have wondered whether the hum could be a signal from an alien civilization, possibly an attempt at communication or an artifact of advanced technology that we do not yet understand. While most scientists view the hum as a natural cosmic phenomenon, it serves as a reminder of the mysteries that still await us in the vastness of space. This mysterious hum also brings to mind the golden records carried by both Voyager 1 and Voyager 2. These records were included as a kind of time capsule, intended to communicate the story of humanity to any potential extraterrestrial civilizations that might encounter the spacecraft. Each record is a gold-plated copper disc containing a selection of sounds and images that represent the diversity of life and culture on Earth. The golden records include greetings in multiple languages, a variety of music from different cultures, and images depicting human life and nature. They were designed to be a message from Earth, a snapshot of our world that could last for billions of years as the spacecraft travel through interstellar space. The inclusion of the golden records reflects humanity's deep curiosity and desire to reach out beyond our solar system. However, there are also concerns about the potential risks associated with sending such a message into space. Some worry that if the records are discovered by a civilization that is not friendly, or if their contents are misinterpreted, it could lead to unintended and possibly dangerous consequences. There is also the issue of privacy and security. By sending detailed information about Earth and its inhabitants into space, we might be exposing ourselves to unknown entities, raising questions about the potential implications of such disclosure. Despite these concerns, the golden records remain a bold and thought-provoking gesture, symbolizing humanity's enduring quest to understand our place in the cosmos. Scientists involved in the Voyager's activities. The story of the Voyager missions would not be complete without mentioning Carl Sagan, the renowned astronomer who played a crucial role in their success. Sagan was a member of the Voyager imaging team, and he advocated for one final round of pictures before the spacecraft's cameras were shut down. This led to the creation of one of the most famous images in space exploration history, the pale blue dot. Taken on Valentine's Day in 1990, as Voyager 1 looked back at the inner solar system from a distance of 3.8 billion miles, this image shows Earth as a tiny speck in the vastness of space. When it came to the Voyager missions, Sagan and his team wanted to create something more elaborate. They envisioned a detailed record that would represent the diversity of human life and culture. This vision materialized as the Golden Record, the time capsule that we spoke about earlier. At a National Space Society meeting in Los Angeles, researchers Rebecca Orchard and Sherry Wells Jensen from Bowling Green State University shared their concerns about the Golden Record on the Voyager 1 and 2 probes. The record, which includes 117 images, sounds of humpback whales, greetings in 54 languages, a 20-minute audio essay on life on Earth, and 90 minutes of music from various cultures, is undeniably human-centered. Orchard and Wells Jensen questioned whether an alien life form with senses or methods of communication vastly different from ours would be able to make sense of it. They pointed out that the combination of sounds and images could create misunderstandings if aliens couldn't interpret them as intended. For instance, greetings could be mistaken for arguments, and the varied music could be perplexing to beings unfamiliar with human sounds. Though Voyager 1 is currently more than 14 billion miles away and won't approach another star system for another 40,000 years, the project raises important questions about how we are perceived by others and the limits of our control over that perception. Orchard and Wells Jensen, while recognizing these risks, also hope that the effort to send a record of humanity will show something meaningful about us, despite the potential for confusion. However, concerns about contact with extraterrestrial life aren't limited to these researchers. Popular culture, through movies and books, has long imagined what could happen if aliens made contact with Earth. Films like Invasion of the Body Snatchers and The Day the Earth Stood Still explore scenarios where aliens arrive with plans that could drastically alter or even replace humanity. H.G. Wells' classic novel, The War of the Worlds, depicts a hostile invasion by Martians, while Arthur C. Clarke's Childhood's End portrays aliens who guide human evolution, but at the cost of profound changes to our world. Even esteemed scientists like Stephen Hawking have voiced concerns about making contact with alien civilizations, fearing that advanced beings might see humanity as insignificant or even a threat. As both Voyager 1 and Voyager 2 continue their journeys through interstellar space, they carry these concerns along with their scientific instruments. Their progress can be tracked in real time using NASA's Eyes on the Solar System app, which updates their positions every 5 minutes. This app offers a fascinating way to follow these spacecraft as they venture further into the unknown. The end is near for Voyager 1. Recently, NASA's Voyager 1 probe faced some technical challenges. In November 2023, it began transmitting confusing signals due to a malfunction in one of its onboard computers. For several months, engineers worked tirelessly to diagnose and resolve the issue. In April, they sent a command to Voyager 1's flight data subsystem, which organizes and transmits the spacecraft's data. This command allowed Voyager 1 to send back its first clear message in months, enabling engineers to identify and address the problem. By May, 2 of the probe's instruments were working again, and after further adjustments, all 4 instruments were back online. These instruments are crucial as they collect information about plasma waves, magnetic fields, and particles in space. For the scientists and engineers who have dedicated much of their careers to the Voyager mission, its eventual end will be bittersweet. The mission has led to countless discoveries and significantly deepened our understanding of the solar system. The findings of the Voyagers have inspired future generations of scientists and space enthusiasts, revealing the wonders of space in ways that were once unimaginable. How long do you think Voyager 1 will hold before it eventually folds? Share your thoughts in the comment section below. Also make sure to like our video, subscribe to the channel, and check out another of our interesting videos. See you on the other side.